Physics Part 68. The law can be expressed in form of an equation, force F, extension of delta L. Removing the proportionality sign gives F is equal to K delta L, where K is a constant known as elastic constant or spring constant. The classic constant, spring constant, is the force per unit extension. The unit of the constant is Newton per meter, Nm. An example, an elastic code has an extended length of 25 centimeters. When the code is extended by applying a force at each end, the length of the code becomes 40 centimeters. For force is 0.75 Newton. Calculate the elastic constant of the code. Extension of code 1.5 centimeter. Elastic constant 0.75 over 0.15, extension in meters, 5.0 Newton per meter. Now it's your turn Number one, calculate the elastic constant for a spring which extends by a distance of 3.5 centimeter. When a load of 14 Newton is hung from its end. A steel wire extends by 1.5 millimeter when it is under a tension of 45 Newton. Calculate A, the elastic constant of the wire. B, the tension required to produce an extension of 1.8 millimeter, assuming that the elastic limit is not exceeded. So here we find another one. Strain energy. When an object has its shape changed by forces acting on it, the object is said to be strained. Work has to be done by the forces to cause this strain, provided that the elastic limit is not exceeded. The object can do work as it returns to its original shape. When the forces are removed, energy is stored in the body as potential energy when it is strained. This particular form of potential energy is called elastic potential energy or strain potential energy, or simply strain energy. Strain energy is energy stored in a body due to change of shape. Consider the spring shown in the figure to produce an extension X. The force applied at the lower end of the spring increases linearly with extension from 0 to a value of F. The average force is half F and the work done, W, by the force is therefore work is equal to average force into extension, half Fx. However, the elastic constant K is given by the equation. F is equal to K delta L. The value delta L is equivalent to X, therefore substituting for F, strain energy is W is equal to 1 over 2 K delta L square. The energy is in joules if K is in newtons per meter, and X equal to delta L is in meters.